In this tutorial, we're going to create toolpaths to cut the wine cellar door that was created in one of the earlier examples. Rather than cut it exactly as we model it though, we're going to show you how you might want to use some of the other toolpathing options that are available in Aspire in order to cut this more efficiently. We'll discuss the pros and cons of that as we go through the example. So to start with, we're going to do a profile cut around the outside of the job in order to make the raised panel. We're going to do a 3D cut to carve the dished area where the grapes are. We're going to V-carve the text, and then to finish off we're going to do a couple of decorative passes with the V-cutter just to etch in a little bit of extra decoration into the top of the part. And that's going to result in what you can see. So let's go ahead and minimize this image and go into the software. The file we're going to start with, we're going to hit Open Existing File, and we're going to go on to the DVD under the Tutorials folder. I'm going to go into the Machining folder, number 13, and into the Files subfolder there, and we're going to open a file called Mac3 Wine Cellar Door Start. Very important you choose the one with the word Start in it. If we hit Open, we can see if we tile the windows, I'm going to tile them vertically. This is an exact replica at the point where we finished modelling the part in the earlier tutorial. In that example, we actually modelled the raised panel using the 3D tools that are in Aspire. We actually did a 2-rail sweep to extrude that border area. Now if that was a custom shape that we didn't have tooling for, or it was something that we weren't able to buy tooling for because the shape was so unusual, that would be an ideal way to do it, and we could go ahead and do a regular 3-axis machining toolpath, a regular rough and finish toolpath in order to cut that. And this part is actually ready for that situation. However, what I want to do in this case is something a little bit more efficient. I'm going to assume that we've got a raised panel cutter that we can use in order to just profile around the outside of the job, so we can actually cut that using a regular 2D profile toolpath. From that point of view, it's actually possible for us to just delete the component that has the raised panel in it. We can either pop up the component manager, selecting the grayscale, and hit the delete key, or we could have just selected the grayscale and hit delete from the keyboard. In this case, with it selected, I'm going to hit delete. It's going to get rid of it, and our 3D view is going to look a little bit unusual. This plane is actually at the edge of the dish. If we look and rotate this up, you can see that the dish goes below the plane. It's probably a little difficult to see, depending how your monitor is. But so in effect though, this is a flat plane with the dish going into it, and that's all we need for the 3D part of this particular job. The rest of it we're going to create using shaped cutters and defining the area where we're going to cut with the vectors. So now the 3D part of our job is ready to cut, we need to prepare the vectors that we're going to use. Now if you remember earlier, the vectors that we've got around our part are not exactly what you would use for borders, because they're separate pieces that we use to do a 2-rail sweep. So the first thing I'm going to do is just delete some of those extra vectors around the edge here. And one nice trick in Aspire is if I select vectors by clicking to the bottom right and drag up towards the left as I am doing here, it'll actually pick them even if they're only partially covered. And so I can go ahead and select those and hit delete. That leaves me with these up here. Remember, if I select this way, it doesn't pick them, because when I select left down towards right, I need to completely enclose the items I want to pick. Again though, if I click to the right and select upwards to the left, it will allow me to pick these without completely enclosing them, and that makes it easier to select and delete them without deleting something else that I'm going to need. What I'm going to do is create a vector around the border again that's actually a closed rectangle. So we're going to create vector, and I know the size of the part is width 18, height 24. I can hit create, close, select that, and press F9 on the keyboard to center it, so you can see it's now around the extents of the job. Now what I'm going to do with this vector is I want to cut around that with a profile shape cutter. However, it's important for me to know how wide the cutting area of that particular tool is, and I can get that from the manufacturer or from drawings that they send me. In this case, I know that the cutting area of the shape tool that we're going to use is 1 3/8 of an inch. So in order to define the edge that this is going to cut to, I'm going to take that outer vector, I'm going to offset it inwards by 1.5 0.375, 1 3/8, hit offset, and that now is going to be the edge that we're going to cut around with our raised panel shaped cutter. Before we start creating the toolpaths, there's a couple of other vectors I need to create and a couple more edits to make. Again, if you remember, when we left the wine cellar example, when we modelled it, we divided this elliptical vector in two to fit the text around. I need that to be closed in order to use it as a boundary to cut the dished area. So I'm going to select both of those vectors, the top and the bottom half. I'm going to come over to join vectors by moving endpoints. That'll join one side of them, and then we'll just say close vector by moving endpoint, and that'll make sure that is a continuous vector again. Last thing I want to do is create a couple of lines that I'm actually going to etch into the top of the door. One of them is an offset of that ellipse that we've just put back together. So with that selected, I'm going to come to the offset selected vectors. I'm going to offset it outwards by 0.2 of an inch. And then I'm going to come to this outer rectangular vector and offset that inwards by 0.3. And you'll see how we're going to use those as we progress in creating the toolpaths. So at this stage we're ready to go ahead and set up the material and start to actually apply toolpaths to the part. So we can go over to the toolpath tab. Shortcut key for that is to hit F12 on the keyboard, and that's just going to take me across, open that toolpath tab and close the drawing tab for me. Next, if we come to the setup material icon, we can see the only 3D part I've got in here is the dish, and that's 0.6 inches thick. Now in this case I want that to be pushed right up to the top surface of the job, so the gap above the model is going to be 0. That means that the edge of the dish will be flush with the top of our part. Remember, this part is 3/4 of an inch thick. That's all correct, so I can come in here and just set the rapid clearance gap, the home position, hit OK, and we can actually start generating the toolpaths. Now the first toolpath I want to do is this profile with my special shaped edge cutter. Now I may not have that edge cutter in my tool database, and so what I need to do is bring in some data or draw some data to allow me to specify it, because it is an unusual shape. It's not a ball nose or a V cutter or one of the more regular shapes we can define inside of a spire. For the sake of speed and convenience, I've already got an outline of our particular form tool drawn and saved as an EPS file. So let's go ahead and import that. File, import, import vectors. I'm right in the same folder as the other files we've been working on in this particular example. There's a file called rpog.eps. If we hit open, we can see that appear in the bottom left hand corner of the screen. If I want, I might want to pop the drawing tab open and just zoom that to fit, and then just click on the drawing tab again so that goes away. Now I want to define this as what we call a form tool inside of a spire, and that means that the software is actually going to look at the vectors, pick the data up and create the tool for us based on that. However, the only part of the tool I need to have drawn is the right hand side of the profile. So in this case I'm going to go select the vector, hit N on the keyboard to go into node editing, and just then use the D key to delete these two spans, and then hit the delete key on the keyboard to actually get rid of the rest of that vector. So this is the only piece I need when I define a form tool. Next, to add that to the tool database, I'm going to go up to Edit, and we're going to choose Tool Database. Now the way that I'm going to define this is to come up here, and I'm going to make sure this is selected, and I'm going to click New, and from there in the drop down list here I'm going to choose Form Tool. The combination of having the right type of vector selected and choosing that from the list is going to generate this profile that you can see here and actually create a tool for us. So I'm going to call this tool Raised Panel OG. That's what the tool manufacturer calls it, and we're going to set up a pass depth of 1/4 of an inch, and essentially the parameters you set for this would be based on what the tooling manufacturer told you was suitable for whatever material you're looking to cut. If I'm happy with that, I can hit apply, and it will be added to the very bottom of my list here. If I want to move that up in the list, I can use the arrows here at the side to move it into my inch set of tools. With that chosen, I can hit apply and hit OK, and that's now defined for me, and so we can go ahead and zoom back out, close the drawing tab again, and now we're actually ready to go ahead and click on the profile toolpath and generate a toolpath with that particular tool. So if you remember earlier, we offset our boundary vector by the amount that the manufacturer has told us that tool will cut, 1 3/8 of an inch. So we're going to select that vector. I'm going to go into the profile option here, and I'm going to tell it the cut depth that the manufacturer recommends for that tool, which in this case is 1/2 inch. I need to hit select and go to the tool database and choose that tool now that we defined and hit OK. And we want to cut outside of this, so that means it's going to put the edge of the tool onto the edge of the part there. If we go ahead and hit calculate, I can see that that's generated a toolpath for me, but if I preview that, we're going to see it's not exactly what I'm looking for. So I can see that I've got the shape in there, but it's actually rounding the corners, and that's standard procedure because on most profile toolpaths you're just cutting the part out and you're not worried about what's happening as the tool rolls around the corners here because the material's been removed. So what we actually want here is for the tool to almost come past the corner before it carries on around the edge so that I get a sharp transition. Now this is an option within Aspire, so if I come up to that toolpath and double click on it to edit it, come down to where it says corners, I have the option here to choose sharp external corners. If I calculate the toolpath again, you can see now that the blue lines that represent the toolpath are no longer rolling around it. In order to preview that, we can reset the preview that we did before, and I can preview the new toolpath, and we can see now that that's the kind of effect I was looking for with that raised panel OG cutter. So let's go ahead and generate some more toolpaths. The next one we're going to do is the finishing toolpath for the dished area, the 3D part. Now that's 0.6 of an inch deep, which is fairly deep, especially for the cutter we're going to use, which is a 1/8 ball nose cutter. So you may want to rough it depending how hard the material is, or depending exactly what type of ball nose cutter you're using. However, one of the features of a dished style model is the fact that the first cut, especially if we use a raster style of toolpath, is going to be very, very shallow because it's always going to start at the edge. So that means the load on the tool is very light. So in this case, I'm not going to rough this, I'm just going to go straight to a finished cut. We've got a ball-nosed 1/8 inch ball nose cutter selected, and I'm going to choose a raster strategy and hit calculate. Now you shouldn't run any toolpath without checking with your tooling manufacturer or your router manufacturer what are suitable settings, especially in terms of depth of cut and the amount of material you're removing, and also your speeds and feeds you're using. But this is one suggested method that you might want to look into or discuss with the tooling or router manufacturer. So if we preview this, again, look out for the fact it's going to start at the edge with a very, very light cut. After that, I'm only taking 10% of the tool diameter, so even when I get down to a depth of 0.6 of an inch, the load on the tool is actually relatively light. If we preview it, we can see that it goes through that, and there's my 3D toolpath cutting into the top of the part. Next, we're going to take the text and select that, and we're going to do a V-carve toolpath. This time start depth is 0, I want to do that right on the top of the part again, and I'm going to select from my tool database a 90-degree V-bit tool. Let's take the default settings and hit calculate. Again, we can preview that toolpath. And then to finish off, we're going to select this line and this line that we offset earlier. We're going to go back to doing a profile toolpath, so basically a toolpath that's just going to follow those vectors. This time though, I want to go down only 0.1 of an inch. I'm going to select that same 90-degree V-bit that we did the V-carving with, and ask the software to machine right on the vectors. So basically what that's going to do is just put the center of the tool onto those vectors and do a single toolpath following exactly the path of those vectors and just etching the tool into the surface by the depth that we've set up here. If we calculate that, we can see how it looks. We can preview that toolpath. If we want to maximize the 3D view, we can see there's our finished part, and once again we're ready, if we want to now, to export those toolpaths and send them to our CNC machine. Let's now take a second to explore some of the concepts that we introduced in this particular tutorial. First, we loaded a part that we'd created earlier in one of the modelling tutorials, and in that we'd actually built the raised panel edge as part of the 3D model. And we could have gone ahead and machined that as any regular 3D part using the roughing and the finishing toolpaths. That would have been relatively time consuming, so the only reason for me to do that is if the profile running around the edge is one that I don't have tooling for, or is too complicated for me to buy the tooling to actually cut that. In this case, we decided to opt for some existing tooling we had that could cut a raised panel ogee into the edge of our part, and just use a profile toolpath to do that. In order to set that up, we needed to define the geometry for the tool, add it to the tool database as a form tool, and we needed to offset the vector by the cutting distance that we wanted that to come in around the edge. After that, it was fairly straightforward for us to generate that profile toolpath, and the only additional option we needed to check was to make sure that it was set to do sharp corners so that the tool didn't roll around those, and it gave us the effect that we can see on the screen. The next thing we did is we decided to cut the 3D part of the model. Now the important thing to realise there is we'd deleted effectively all the components except that dished area, but because that was the only area that we were actually applying a 3D toolpath to, it's the only part that needed to exist with regard to actually cutting it. Every other toolpath we did in this part was either a 2D toolpath or something that purely related to a depth that we'd set. For instance, the V-carving was set off the 0 off the top of the material, and so were the profile cuts that we etched into the top too. So neither of those needed to have any kind of 3D data represented for us to create those toolpaths. Again, just to reiterate, the only part that did need that was the area where the dished grapes are, and that did have the 3D area created, and we were able to assign a finish cut to that. The last thing, just to mention, was the fact that in that dished area we didn't do a roughing toolpath. In this case, we decided that our tooling would be able to cope with that because the initial cut is very, very light around the edge. After that, it's only stepping over 10% of the tool diameter, and so as it works its way through, the loading on the tool is fairly light. Again, you shouldn't just take it that your machine, your material and your tooling will be able to do that. You should talk to the manufacturers of the various products in order to ensure that you're using safe parameters whenever you do machining with your CNC. And that concludes this presentation.